So today we'll be testing our layer 2 solutions. It is essential for ensuring the functionality, security and performance of layer 2 solution. It helps to identify and resolve potential issues before deployment. So here are the types of testing. We first have the unit testing. Unit tests focus on individual components or units of code. They ensure that each unit functions correctly and meets its intended purpose. They are typically written by developers and run frequently to catch errors early in the development process. We next have the integration testing. Integration tests verify that different parts of the system work together correctly. These tests are designed to expose issues that arise when multiple units are combined, ensuring the seamless integration of components. End-to-end testing covers the entire system from start to finish. They simulate real-world user scenarios, validating the flow of data and interactions between different components, including user interfaces, backend services, and databases. We finally have the performance testing. These performance tests evaluate the system's ability to handle high loads and respond quickly to user requests. They are essential for ensuring scalability and responsiveness, especially in environments with high transaction volume. To set up the testing environment, we first need to install the necessary tools. The tools which are necessary provide framework, libraries, and utilities for writing and running tests for layer 2 solutions. We then need to select a testing framework. Choosing a suitable testing framework that aligns with our project's requirements and preferences. Popular options include Mocha, Jest, and Jasmine, which provide a structured environment for writing and executing tests. Then we need to set up a development environment. We need to create a development environment that is dedicated to testing. This environment should include the necessary tools, dependencies, and configurations required to run and verify the code. We finally configure the test environment. This includes setting up test networks, defining test cases, and configuring the test framework for optimal performance. Installing the necessary tools and libraries is crucial for building a robust testing environment for Layer 2 solutions. These tools provide the foundation for writing and running tests, ensuring the quality and reliability of our solution. Popular tools include Node.js, Truffle, Hardhat, Mocha, and Chai. Node.js is a JavaScript runtime environment, while Truffle and Hardhat are frameworks specifically designed for developing and testing smart contracts. Mocha is a JavaScript test framework that allows you to write and execute tests, while Chai is an assertion library for writing clear and concise test assertions. This command here will help you install Truffle, Hardhat, Mocha, and Chai. To create a new project, we first initialize the project. We use the Truffle framework to initialize a new project for testing Layer 2 solutions. Truffle provides a robust environment for managing and testing smart contracts. Then, the project structure should be organized for efficient testing. It includes directories for contracts, tests, and configuration. So this command here creates a new directory called layer 2 testing project and initializes a truffle project within it. The truffle init command sets up the necessary files and configurations for the project, including a truffle config.js file that defines the network and compiler settings for your project. Unit tests, as told before, are crucial for verifying the functionality of individual components or units of codes within a layer 2 solution. They isolate and test specific functions or methods, ensuring that they perform as expected. Unit tests are typically written by developers and are executed frequently throughout the development process to catch errors early. For layer 2 solutions, unit tests often focus on testing smart contract functions. Smart contracts are essential components of layer 2 solutions, and it is crucial to ensure that they operate correctly and securely. Frameworks like Mocha and Chai provide a robust environment for writing and running unit tests, enabling developers to define test cases and verify expected outcomes. In this unit test, it first imports the contract simple rollup and creates a testing suite. Then we write the deposit test to ensure that an account can deposit either into the contract and balance is updated correctly. The withdrawal test then ensures that an account can withdraw either and the balance is updated accordingly. Integration tests are essential for verifying that different components of a layer 2 solution work together seamlessly. They go beyond unit testing, which focuses on individual units of code by testing the interactions between multiple components. These tests are crucial for ensuring that the system functions as a whole. For layer 2 solutions, integration tests often involve testing the interactions between smart contracts. This includes verifying that smart contracts communicate correctly with each other, exchange data accurately, and execute transactions as expected. Testing frameworks like Truffle and Hardhat provide a robust environment for writing and running these integration tests. This integration test imports the contracts, simple rollup, and ZK verifier and creates the test suite. Then the test checks if the contracts are deployed properly. It also verifies that an account can deposit either into the simple rollup contract and that the balance is updated accordingly. It then checks if the proof can be submitted to the contract simple rollup and whether the proof is verified correctly by the ZK verifier contract. End-to-end tests are crucial for simulating real-world user interactions and validating the complete workflow of a layer 2 solution. They ensure that the system functions as expected from beginning to end, encompassing user interfaces, backend services, and smart contracts. E2E tests are essential for identifying issues that might arise when multiple components interact, including potential bottlenecks, data inconsistencies, or unexpected behavior. They provide a comprehensive view of the system's functionality and performance under real-world conditions. Testing complete workflows, including user interactions, network communication, and smart contract interactions, using tools like Selenium, Puppeteer, or Cypress for automated browser interactions, ensuring seamless integration between different parts of the system, including front-end interfaces, back-end services, and smart contract deployments. This script uses Selenium WebDriver to automate browser interactions for testing a web application running locally. We first import the Selenium WebDriver. We then create an asynchronous function and initialize the WebDriver. Then we navigate the browser function to the local web application. Then we locate the element with the name attribute deposit, input the value 1, and then locate and click the element with the name attribute submit. Then we wait for the success message and log the text context of the success message and quit the WebDriver. Then we need to do the performance testing. Performance testing includes measuring scalability and evaluating efficiency. Performance testing evaluates the scalability and efficiency of the layer 2 solutions. It helps determine how well they handle high transaction volumes and respond quickly to user requests. It involves measuring transaction throughput, which indicates the number of transactions processed per second. Then, performance testing also measures latency, which represents the time taken for transactions to be processed and confirmed. It also analyzes gas costs, the fees associated with executing transactions on the network to optimize cost effectiveness. Tools like Apache JMeter can simulate real-world user activity and provide insights into performance metrics. So, to do performance testing with JMeter, we first download and install JMeter. So, Apache JMeter is a popular open source performance testing tool. We download the latest version of JMeter from the Apache website. We install the software on our computer and ensure that the necessary prerequisites are met. We then configure JMeter for blockchain transactions. JMeter can be customized to simulate blockchain transactions. Define test plans that include specific endpoints, transaction types, and desired load parameters. We then run performance tests. Run the configured test plan using JMeter. Monitor real-time performance metrics such as transaction throughput, latency, and gas consumption. Analyze the data to identify bottlenecks or areas for improvement. Then we finally analyze the performance results. After the tests have completed, we analyze the results to gain insights into the performance of our layer 2 solution. We identify the potential issues and areas for optimization based on the metrics we collected during testing. Then, security testing is a critical step in developing layer 2 solutions. It involves identifying and mitigating vulnerabilities that could compromise the security of the system. By performing comprehensive security tests, developers can ensure that their solutions are resistant to attacks and protect user assets. Security tests involves identifying vulnerabilities, using security tools, and mitigating risks. Security testing involves analyzing code for potential weaknesses, including vulnerabilities that could be exploited by attackers. This process includes static code analysis, which scrutinizes the code for common vulnerabilities, and dynamic code analysis, which tests the system in real world scenarios to identify potential flaws. Tools like MythX and Slither are valuable for security testing. MythX is a smart contract security audit platform that provides comprehensive analysis and vulnerability detection, while Slither is a static analysis tool that analyzes Solidity code to identify potential vulnerabilities. Once vulnerabilities are identified, it's essential to mitigate them by implementing appropriate security measures. This includes fixing the underlying code, implementing access controls, and adopting best practices for secure development. So, testing with MythX. MythX is a valuable tool for ensuring the security of smart contracts within Layer 2 solutions. It provides automated security analysis, identifying potential vulnerabilities that could be exploited by the attackers. Integrating the MythX into your development workflow helps catch security issues early, thus preventing costly and potentially damaging exploits. MythX's analysis goes beyond simple static analysis, utilizing advanced techniques to detect a wide range of vulnerabilities. The platform provides detailed reports on identified issues, including their severity, potential impact, and recommended mitigation strategies. This information enables developers to address security risks proactively, enhancing the overall security of their layer 2 solutions. So here is the code to test with the MythX. So now let us look at continuous integration for testing. Automated testing. Continuous integration pipelines automate testing tasks, ensuring that every code change is thoroughly tested before deployment. We have CI tools. Tools like GitHub Actions and Jenkins provide a framework for setting up CI pipelines and automating the testing process. Then, the testing on code changes. When code is pushed into a repository, CI pipelines automatically trigger tests, providing instant feedback on the quality and functionality of the code changes. Continuous integration is crucial for ensuring the quality and reliability of Layer 2 solutions. CI pipelines streamline the development process by automating testing tasks, allowing developers to focus on building and improving their applications. So here is an example. So here are some best practices for testing layer 2 solutions. We have to make comprehensive test cases. Thorough test cases are essential for comprehensive coverage. Each test case should target a specific functionality or scenario. Ensure that all critical components and interactions are covered. We then regularly need to update the tests. As layer 2 solutions evolve, it's crucial to update test cases. Modify tests to reflect changes in code, features, or network configurations. Regular updates ensure that the tests accurately reflect the current state of the solution. Manual and automated tests. Combining manual and automated testing offers a robust approach. Manual tests provide insights into user experiences and edge cases. Automated tests ensure consistent and frequent execution, reducing manual effort and time. Testing layer 2 solutions in real world applications provides valuable insights into the performance, security, and user experience. Case studies of successful testing implementations showcase the practical application of testing methodologies, highlighting best practices and lessons learned. These case studies demonstrate how rigorous testing can identify and address potential vulnerabilities, optimize transaction throughput, and enhance overall user satisfaction. By learning from real world examples, developers can refine their testing strategies, improve the quality of their layer 2 solutions, and foster greater confidence in their applications. Here is an example. We will be testing Uniswap on Arbitrum. Uniswap is a decentralized exchange protocol, integrates with Arbitrum, a layer 2 scaling solution, to enhance its performance and efficiency. Testing this integration is crucial to ensure seamless operation and positive user experience. Testing workflows encompass various aspects, including placing orders, executing trades, and verifying transaction confirmations. This involves simulating real-world user interactions and assessing the functionality of the integrated system. Uniswap utilizes tools and frameworks like Mocha, Chai, and Hardhat to automate tests and validate code quality. So here are a few tests. So first is the workflow testing, simulating trades, order placements, and transaction confirmation. Then we have the smart contract testing, verifying code logic and interactions with Arbitrum smart contracts. Then the performance testing, measuring transaction throughout latency and gas consumption. Then the security testing, identifying and mitigating vulnerabilities in the integrated system. We also have another example. This is testing Axie Infinity on Ronin. Axie Infinity, a popular blockchain-based game, utilizes the Ronin sidechain to enhance its scalability and performance. This sidechain, specifically designed for Axie Infinity, undergoes rigorous testing to ensure a smooth and secure gaming experience. The testing process involves a comprehensive approach encompassing various aspects to guarantee the stability and reliability of the Ronin network. Axie Infinity implements a robust testing strategy focusing on key performance indicators such as transaction throughput, latency, and gas consumption. These metrics are continuously monitored and analyzed to identify areas for improvement and optimize the performance of the Ronin sidechain. This continuous optimization ensures that the network can handle a growing number of users and transactions while maintaining a high level of efficiency. So here are challenges while testing layer 2 solution. So first comes the complexity of the multi-layer interactions. Testing the layer 2 solutions involves navigating intricate interactions between multiple layers from the base blockchain to the specific layer 2 implementation. This complexity requires careful consideration of data flow, communication protocols, and potential points of failure. Then we'll also be handling large volumes of data. Layer 2 solutions aim to process transactions more efficiently than base blockchains. This necessitates testing with substantial data volumes to accurately assess performance under real world conditions. Generating and managing large data sets for testing can be challenging. So here how we overcome these test challenges. We adopt the best practices. So implementing best practices for testing layer 2 solutions is crucial for its success. Adhering to industry standards and guidelines ensures that our testing process is thorough and effective. This involves establishing clear testing objectives, developing comprehensive test cases, and using appropriate testing tools. We also can use advanced testing tools. So advanced testing tools can greatly enhance our testing efforts. Specialized tools for performance testing, security auditing, and contract analysis are invaluable. These tools provide insights into performance bottlenecks, security vulnerabilities, and contract logic errors, helping you optimize our layer 2 solutions. Also, continuous learning and adaptation. As the blockchain landscape is constantly evolving, continuous learning and adaptation are essential to stay ahead of the curve. We need to stay informed about new testing methodologies, emerging tools, and best practices. Adapt our testing strategies to keep pace with advancements in the layer 2 ecosystem. So, thorough testing is paramount for the success of layer 2 solutions. By rigorously testing our solutions, we ensure their reliability, security, and scalability. We regularly need to update and improve our testing processes to keep pace with the ever evolving landscape of layer 2 technology.